Alright, now we're ready to see a real-life example. We've called it Thief and Alarm. Imagine that you buy an alarm to a house to prevent thieves from going into it. If the thief goes into a house, the alarm will go off and you'll get an, for example, SMS notification. However, the alarm may give a false alarm in case of an earthquake. Also, if there is a strong earthquake, the radio will report about it, and so you'll get another source of notification. Here's a graphical model for it. What is the joint probability of the four random variables: thief, alarm, earthquake, and the radio? It is given by the following formula. To fully define our model, we need to define these four probabilities. Let's start with thief and earthquake. What is the probability that there is a thief in our house? Let's define it as 10 to the power of -3. That is, 1 in 1,000 houses has been robbed. What is the probability of an earthquake? Well, let's say that it is 10 to the power of -2. The earthquakes happen about once in 100 days. Now we need to define the probability of alarm given the thief and an earthquake. So those will be four numbers. If there is a thief in our house, the alarm will go off for sure. This is indicated by the ones in the lower row. If there is no thief and there is no earthquake, then the alarm has no reason to send us signals. However, if there is no thief but there is an earthquake, the alarm will notify us with probability 1/10. Finally, we need to define the probability of the radio report given an earthquake. If there is no earthquake, the radio report has nothing to tell us about, and so it will not report about it. However, if there is an earthquake, the radio will report with probability 1/2. That is, it does not report about some small earthquakes. So here's our model again. I changed the annotation a bit so it would be a bit shorter. So for example, instead of writing t equals 1, I would write simply t, and if I want to write down the event that didn't happen, for example t equals 0, that there is no thief in our house, I would simply write a bar over the letter. Alright, so imagine that you went somewhere out of your house, for example for a work, and you got a notification from an alarm system. So you want to estimate the probability that there is a thief in our house, given that there is an alarm, given that we got a notification from an alarm. So this would be the probability of thief given the alarm. Alright, so let's use base formula to compute this probability. So this would be the joint probability that there is a thief and alarm over the probability of the alarm. Alright, now let's use the sum rule, and we'll add another variable, the earthquake. So this would be a thing like this. So this would be the probability of thief, alarm, earthquake, plus the probability of thief, alarm, and not earthquake. And we'll do the same trick for the denominator. So this would be the probability of thief, alarm, earthquake, plus probability of thief, alarm, and not earthquake, plus another two terms with no thief in our house. So alarm, earthquake, and finally probability that there is no thief, alarm notification, and no earthquake. Alright, now let's compute these terms. Let's start with the first one. So what is the joint probability of these three events? We can write them down using the model. So this joint probability actually equals from this model to probability of alarm given thief and an earthquake times the probability of thief and probability of an earthquake. Alright, where do we get these numbers? So the probability of the thief is here. It is this number. The probability of an earthquake is this number. And finally, the probability of alarm, given that there is a thief and an earthquake, we can get it from here. So it would be this. So finally, we get 10 to the power of minus 3 times 10 to the power of minus 2 times 1. So this would be equal to 10 to the power of minus 5. Alright, now let's compute some other probabilities. For example, let's compute this probability. So what is the probability that there is no thief, there is no earthquake, and there is an alarm? So again, we can write it in a similar way. It will be the probability of alarm given no thief, no earthquake, times the probability of no thief and probability of no earthquake. Alright. What is the value of the first term? This is the probability of alarm given that there is no thief and no earthquake, so it is 0. So finally this probability would be 0, so we can cross it out. Alright, we can compute all other terms in a similar way, and if we do the math right, we'll get the value of around 50%. So this would be somewhere around 50%. So the probability that there is a thief in our house if we get an alarm notification is around 50%. So would you trust all your belongings on the fair coin? Well, certainly not. So you get into a car and head to your house, and on the way home you get another notification from the radio report. So you heard the radio report that there was an earthquake in the area near your house. And now you want to estimate another probability. The probability that there is a thief in your house, given that you heard an alarm and also a radio report. Alright, so we can do this in a similar way. So this would be the ratio between the joint probability. So this is thief, alarm, and the radio report over the probability of alarm and the radio report. Alright, let's add the missing variable to the numerator. This is an earthquake, and missing variables to the denominator. Those are the thief and an earthquake. So we'll have again something like this. So probability of thief, alarm, radio report, and an earthquake, plus the probability of thief, alarm, radio report, and no earthquake. Alright, so this is a sum rule again. And the same thing will be in the denominator. So probability of alarm, radio report, thief, and earthquake, plus probability of alarm, radio report, thief, not earthquake, and finally, not finally, but we'll need a bit more terms. So alarm, radio report, not a thief, and alarm. And now finally, the probability of alarm, radio report, and no thief, and no earthquake. Alright, let's compute this in a simple way. So this term from our model equals to the following formula. So this is probability of an alarm given thief and an earthquake times the probability of the radio report given earthquake times the probability of the thief and probability of an earthquake. You can find these values in this table. Also, let's compute, for example, the probability that there was no earthquake, there was a thief in our house, and there was a radio report. In this case, the one of the terms, the probability of the radio report given that there is no earthquake is 0, so this term would be 0. And also this term would also be 0. So finally we get the value of around 1%. So you come home and so you get the probability of 1%, you think that it is a fairly small probability, and so you come back to work. But in the evening, when you come back home, you see that your house was robbed. And you ask yourself, why did it happen? It seems like we compute all the probabilities correctly. However, it turns out that we defined our model in the wrong way, since actually there are more thieves when there are earthquakes. So our model should look like this.